All right, friends, what kind of questions did we see on 212 that I can help you out with? What questions on page 175, 176 can I help you out with? Seem all right? So, of course, yesterday we, kind of went off subject a little bit, but, it happens. But basically, I was talking about we don't have just only linear regression. We have all kinds of regression models that could take place. Yeah. 8? I like how there's two number 4s. Number 8. Approximate the residual value for point A. Okay, number 8. All right, so point A looks to be about 5, 25. You might have had it as right around there, but not exactly. To what? Well, approximate the residual value for point A. So I looked, and it looked like point A is between 4 and 5.
Sorry, that's my bad. I was
All right. Use the regression model to answer each predicted value. Okay. Residual value of point A is positive or negative. So this is from point A. So this would be negative because it's below our line of best fit. In this case, it looks like it's trying to be an upside down parabola. Approximate the residual value for point A. Show your calculation. It's kind of... So if I went up to from 0.5, so I'm looking on the graph. So if I was at 5 here, so let's say this is point A, but then I kind of went up to it and then over, that looks like it would be at, this would be the 0.5 comma 50. And so it would be 25 minus 50, so negative 25. I would say that would be the approximate residual value. Okay. Obviously, there's some flux in there. Like if you said, well, I think it looks like 528, then you're going to have slightly different. The reason it's a negative answer is because it's below the line, but that's how I would go with that. What else did you see on here? Let's see, the point that looks like it has the smallest residual value would probably be point D as far as the 4 points that are listed. And are there any outliers that influence this data set? I'd say point B would be one of the outliers. C could be because it could have moved it up a little bit, but I think point B has drawn it down a little bit more. Point A might be, I'd say point B is the one that's wouldn't have the biggest influence, but I'd say maybe A, B, and C, A, B, and C might be outliers. Theoretically, A and B are the biggest ones because point C doesn't have that big of a residual away from where it actually finds out. What else we see? We're good? All right, I want to play on my calculator. So let's walk through 213, so page 177. So these might be some things that we might come across. It says, is the length of a jury trial related to the amount of times it takes the jury to deliberate the verdict? Statistics from a small subset of trials are provided. All right, so I want to, that's on y equals, on that there. I'm going to go stat, edit, clear. All right. Will somebody read down that first column for me, starting with 4? Start maybe, 10, 2.5. Anyone want to take over? 6.5. Am I the only one up here? Oh, clear. 10, 2.5. 6.5. Oops, 6.5. 6.5. Okay. 3. 4.5. 5. 12. 18.
5,
5,
10.5.
10.5. Okay, so in column 2, with 4, what is the, oops,
0.5.
0.5,
2.
2,
Yep. 1.5.
1.5,
3.5.
3.5,
5.5.
5.5,
2.
2,
3.
3,
4.5.
4.5,
3.5.
3.5,
8.
8,
2.5.
2.5. Whoa, dude, go
And
to.
that one.
Oh, that's the problem. All right, so after, let's see, delete that. So 2.5,
3.5.
and then 3.5, is that the last one?
Should be. Yeah.
Okay, I hope so. Yay. All right, so once you have your data plugged in, obviously your X value is the length of a trial. The Y value is your length of jury deliberation. So I can go, my stat plot's on, so I can go to zoom stat. So it appears it could be somewhat linear. Agree? So create a linear regression. So you go into stat, and it said linear regression, so that we know we're going to try and find a straight line. And it's down to number 8. L1, L2 sounds good to me. Calculate. So that's my linear regression. So my R value is roughly 0.76 rounded to 2. Explain the meaning of this in the context. It's, I guess, a kind of strong correlation, for our line of best fit. Of course, things that would help out that R value to determine if this is good or not is to have much more data plugged in rather than just 10 data points. Explain the meaning of the slope. Okay, so the slope is 0.24. Agreed? So let's go 0.24 over 1. So the jury deliberation in hours increases by 0.24 hours over each 1 hour of the length of trial. Okay, so you talk about what it did in the Y direction over what it did in the X direction. Explain the meaning of the Y-intercept. So the Y-intercept is going to be 1.3 roughly. Okay, that means that a jury is going to deliberate for 1.3 hours for a trial that was 0 hours in length. That's kind of, it's an outlier. It's extrapolating the data. Of course, a jury isn't going to take 1.3 hours to deliberate for something that took 0 time to do. Could you imagine you're on, okay, Mr. Stirrup, you're charged with throwing oranges at people. How does the jury find you? Guilty. Wait a minute. You didn't even have a trial. So, predict the length of the jury deliberations for a trial that lasts 8 hours. All right, so what I can do is I'm going to go Y equals, hit vars, then to statistics, over to equation, hit enter, hit graph. I want to do something that takes 8 hours, so I'm going to go second calculate a value. I'm going to plug 8 in. So if for number 5, jury that takes 8 hours is, or a try, predict the jury length. Oh yeah, jury length. So they'll take about 3.2 hours rounded to 2 decimal places if you had an 8-hour long trial. Predict the length of a jury deliberation for a trial that lasts 40 hours. 40 will probably be off of our screen, so you would want to zoom out. That way we can know we're going to include 40, and then I'm going to go second calculate a value at 40 hours. So it looks like they would deliberate for 10.9 hours. Is that a good thing or a bad thing? Should we accept that or not? It's kind of an outlier, but we don't use outlier for this. What's it called? Extrapolation. And extrapolation, though it's used very often, is not very a good thing. Predict the length of a trial when the jury took 10 hours to deliberate. Okay, so this means I need to find a value for y. So the best way to do this on the calculator is you're going to go y equals 10. So that's going to be a horizontal line. And so now I want to find the intersection of those. So second, calculate an intersection. It says first curve is the blue, second curve is the red. Do we want to guess? Heck no. So if it took them 10 hours to deliberate, that means that the trial would have been 36.4 hours in length, rounded to 1 decimal. Which, if any of the above predictions are invalid, I'd say this one would be invalid because it's outside of our data. It's definitely extrapolation. The number 6, where it lasts 40 hours, is also extrapolation. So I'd say they're both invalid because they are extrapolation, again, outside of our data set. And then calculate the residual for a trial that took 12 hours. I'm on problem number 9. So 12 hours. So we have 12 given to us. 12 comma 3.5, is that what they said? Go here.
Yes.
12 comma 3.5. Okay, so what I want to do with this is I'm going to go back to my calculator. So this is the actual data point that was given. So we want to figure out, I'm going to turn off my second equation, clear that. I'm going to go back to graph, there it goes. And then we're going to go second, calculate a value at 12. So 4.14. So that's at 12. So 12 comma 4.14 is 12 comma 4.14. Okay, so this is what our data showed. This is what our model showed. Okay, so think about this. The point 12 comma 3.5 is here. So that's what that shows, but that's what our data shows. Our model, because of our line of best fit, would show 12 comma 4.4. Okay, so is that residual going to be above or below our line of best fit? Our line of best fit's here, so it's above it. So I'm going to go 4.14 minus 3.5. So doing some math. 0.64, positive 0.64. Okay. Create the residual on the calculator. In your own words, describe what the residual plot shows. What conclusion can you come up regarding the regression model? So let's see. Stats, calculate linear regression, because I forgot what it said. So we have an R value of 0.76. I'd say it's a good interpretation. Again, I would always support that the more data, the better we're going to be. Only having 10 data points is not an incredible amount. Is it valid to argue longer trials directly cause longer jury deliberations? Do you ever think there was a quick trial that the jury took forever to figure out guilty or not guilty? Yeah. But there's also, have any of you been on jury duty by chance? Well, if you're 18,
I might get it soon.
Okay. 1 more month? Okay. So, jury duty is a great civic duty, and I highly recommend if you get selected, yes, it is an inconvenience, but it is your civic duty to be a part of it, because if you ever were on trial, you want to be judged by your peers. You don't want, and there's all kinds of people say, why don't you just get all the old people to do it? Like, no. I don't want an 80-year-old who, can't figure it, But there's always the one guy. I've been on jury duty now 4 different times. And I've been on 3 trials. And you're sitting in this trial, and you always get the one guy, all right, I'm going to be the the boss. Sit down there, cupcake. And it's always the guy who has a shirt that's partially untucked. His belt doesn't match his shoes. I'm sorry, I have a big problem with people that belt and shoes don't match. Okay, brown belt, black shoes. You're you're really low on my totem pole. Yeah. So, but there's always the one guy who wants to do it. But then there's always the one guy going, well, hypothetically. It's like, dude, we're looking at the facts. No hypothetical. And there's always the one guy who's going to sit there and just be the albatross around my neck in a jury. It's like, well, are we seeing all the facts? I'm like, don't you think the attorneys gave us all the facts? Don't you think this was all? Well, there might be more facts. Of course there's more facts, but we're judging based on what is presented. So there is always that one time that you will have the blessing of being on a trial, and you get the one girl or one guy or one girl who you get 11 people that are saying guilty or not guilty, and you get the one that's sitting there, and all of a sudden you go to a hung jury, and you're like, I just gave up 30 days of my life to be on this. Majority of the time, there's very few situations where it doesn't. It usually goes to a hung jury, which means then they dismiss everybody, they get a whole new thing, and they go through a whole new trial. And so, and a lot of times you get the one person who's just being that way, and then like the attorneys will come in and talk, the judge will talk, going, why do all these people, and what are you seeing? And because they're trying to figure out, because maybe that one person truly does have a valid argument, rather than just saying, I want to give up, I'm getting 21 cents an hour to be here, so I want to get as many hours as possible. So it gets crazy. So I guess there's all kinds of ways to argue that, because being that you're dealing with society, you're dealing with your peers, there's always that one person that's going to take way longer. So use a scatter plot for each question. Sketch where you believe the linear regression would be. So if you were to try and draw one in, obviously it's going to be there. Use your regression to predict the response variable value to the explanatory value at 40. So I'm not going to make you draw a line of best fit. I mean, we're going to plug data in. You're going to get the equation. The thing is, there's about 20 of you in here. If we added a line of best fit, there's probably 20 different answers that are all relatively close to each other. Estimate the residual for the point that appears to be an outlier. Well, that outlier is obviously at the point 35,000. I think that's 5,000 or 6,000. 2, 4, 6, 6,000. Yeah, so 30, 6,000. So it's obviously a positive residual value. How far do you think it's above? 4,000 above. Explain why you should not try to fit a straight line, or try to fit a straight line into a curved data set. Well, if you're showing a pattern of it's curving, don't go with linear. If you try and plug that in, if you did the R value, if you plug that data into the calculator, if you plugged in the linear regression, your R squared value is going to be lower than if you plugged in a quadratic regression, because that does look like it's trying to be a parabola. It doesn't have the left side of it, but I would say that would take place. Sketch the curve regression. Does everyone agree on page 178 bottom that you could make a curve out of that data a lot easier than the data? And if you're not looking at it, it's basically and then you got this one random point. So linear regression looks like that. Quadratic regression would look something like that. So quadratic seems to fit along with it nicer. So guess what, friends? You are all here today. We just got this assignment done. Therefore, if you're here, this is going in for you. If you're not here, guess who has to do the work? Friends, play dumb with the people who weren't here, saying, hey, do you have the homework that I can copy? Oh, no, Mr. Stirrup collected it. Wink. Got it? Yeah, I just recorded.